Programming. I'm Kamachi, Assistant Professor, PSN College of Engineering and Technology, Tirunelveli. I'm going to study about abstract data types. In programming, normally each programming is broken down into modules, so no routine should be exceed a page. Okay, so each program, each module has a logical unit. So specific modules will do specific jobs. So one module will call the another module. So abstract data type used for breaking many modules. So we can easily call each other and we can easily do our task. Modularity. So modularity, what is the advantages? So modularity, different modules are compiled together. This will use for debugging easier. Okay, several modules can be implemented and executed simultaneously. So modules can be usually enhanced and we can use. So abstract data type is the extension of modular design. Okay, so abstract data type is for operations like union, intersection, complement, we can use abstract data type. So abstract data type can be implemented once we can write in a program and we can call in any part of a program. So basically a small program is written and we can implement again and again. We can call each model and we can use it again and again. So what are the types of abstract data type? So we are going to list abstract data type, stack abstract data type and queue abstract data type. So we are going to see today stack abstract data type and queue abstract data type. So stack abstract data type. Normally stack abstract data type we use the following linear data structure. For linear data structure, last in first order principle. So abstract data types use models and models. Okay, so here we are going to insert a data in single direction. So insertion and deletion occur only in the one side. So that one side is called top. Over here in the example we have seen A, C and B. So top is in the upper level. Only at the top that data only will be insertion or deletion. The top of the data only is going to be changing. So example for how you could imagine it, pile of coins and stack of trays in cafeteria, how they are arranging. So only upper the top coins and top of the stack we are going to change. So operations in stack, normally fundamental operation going to perform is push and pop. So two operations we are going to perform. One is push and pop. So operation on stack is going to happen on the top of the stack. So push. So as a name already it has explained, we are going to insert an element on top of the stack. So every time a push operation occurs and top is incremented by 1. So here is an example. So normally it is stack is empty, then it's -1 actually, top is -1. After inserting element 10, the top is incremented by 1, so top is equal to 0. Then next time 20 is inserted element, so top is into 1. So insertion happens on top. So pop. So we are first in push we have inserted. So next we are going to pop. So as the name suggests, it's going to delete an element with the help of the top of the stack. Okay, so it's called pop operation. So pop operation normally incremented by -1. So every operation happen, the top pointer will be incremented -1. Okay. So here see actually 20 we are deleting, and next the top become -1, and again we are deleting 10, it become -1. So 1, 0 and -1. So top is decremented using the point operator. So what are the exceptional conditions in stack? So stack editing, there will be two exception conditions when we attempt to insert an element when stack is full. So there will be capacity for the stack. So if it is full, it will come under conditions overflow. Again, underflow, attempt to delete an element when stack is empty. So there is no element, we are going to delete, there is no element, so it will have a condition underflow. So it cannot be deleted. So these extreme two conditions will happen. So these are the exception conditions. Next, for implementing the stack can be implemented using arrays and pointers. So array implementation. So we are in this implementation, each stack is going to associate with a pointer. Okay. So top pointer we are going to for push an element x, top pointer is incremented, and then we can going to set stack of top equal to x. Okay. For push an element, top is decremented, so top pointer will be returned. Okay. So what we are going to do is we are going to push and pop using the stack of top array. Okay. So every time we use the increment and decrement happens in the stack of top pointer. So pop an empty stack and push and full stack will exceed the boundary conditions. So these two conditions are being taken care of. So we are going to push an element x to the stack. So that time top pointer will be incremented, then stack will be set to stack of top equal to x. Next time to pop an element, the stack of top will be returned first and top pointer will be -1, so decremented. So first these conditions will be happening. So here you check, there is a program for that. So to push an element on a stack. So you see, first if it is full, we check it is full or not. So itself, if it is full, it will not go to the program at all. So error will be saying full stack. If it is not full, okay, top will be incremented +1, then s of top will be the top whichever is the higher number will be saved to the x. So element is saved to the higher position. Okay, it is full, we can return the value as array as return value equal to 1. So it will give an error full stack when top and array size is same. So it means it's a full stack. So next we are going to pop an element for a stack. So it will check it is very empty or not. So it happens to here in empty, we are going to check it is my top is equal to -1, it will return 1. So it will error, it will display the error empty stack. If not, the x of top is the element goes to the x of top and -1 happens. So next element to be saved in top. Okay, the pointer is decremented. S of top value goes to x and we are going to pop that element. Okay, next the top is decremented to point the next element. So to return the top element, so we are giving returning whether it is empty or not, and you can return the element. So whatever is the top of the element, we are going to return the element, else it will say stack is empty. Okay, now we are going, before we studied about array implementation of stack. Okay, we use pointers like that. Now we are going to same stack operations we are going to doing linked list implementation. So push operation is performed by inserting element in the front of the list. Pop operation is going to delete at the front of the list. So top operations return the element in the front of the list. Okay, so everything will be in front end only. Push and pop will be in the front end of the list. So Here, there we are studying about array implementation. Here we are going to study about linked list implementation. So there is a diagram about that. So we are going to push 10 and push 20. They are written popping 20, and we are going to push 15 and popping push 25. So push and pop happening one by one. It was happening in this diagram. First push operation happen, then again 20 is inserted, then again 20 is popped, that is deleted, then again 15 is inserted and 25 is inserted. So result is 10, 15 and 25. Okay. So this is the linked list implementation. So we have first the top stage to 10. Okay, first element. Next 10 goes second element goes the top value goes to the 20 element. Next 20 is deleted, so top corresponds to 10 element. And again 15 is inserted, so top changes to 15 element. Here at 25 is inserted, so top changes to 25. So top is the first list of the implementation. So this is a program. So linked list implementation. So we are going to use a structure format for this. Structure is used for. So first we are using a pointer. So struct node star stack. So then we are checking it is empty or not using that declaration. Then we are going to create a stack and make empty, and these are the various function declaration we are going to use. Okay. So structure node actually consists of element and node of next. So routine for there is a routine for this is empty or not. So if s of next equal to null, we are going to set return 1, so it's empty. We are going to check if it is equal to null, it will return 1, so I will say this rank is empty. So for creating an empty stack, okay, we are getting empty stack, we are going to allocate some, we are going to create stack. So mlog is the memory allocation size of struct node. So if s equal to L, we are s equal to null, we are going to put an error out of space, okay, or else we are going to invoke the make empty routine, okay, then we will return null. Okay, make empty routine will say we will check s equal to null, okay, then we will create a stack first, or else it will pop the value. So to push an element in a stack in linked list, okay, it will create a structure and it will check it's out of space or not, else it will push an element. So element is x is 7 temp cell of element, and s of next goes to the temp cell of next, and temp cell equal to s of next. So basically what happens is we are going to save the top of the value in s of next. Using temp of element and temp of next, we are actually saving the pushing, that is inserting an element on a stack. So return the top. So if it's not an empty element, we are going to return as an empty stack, okay, or else it will return the next value, s of next value, there will be a element that will be returned. Okay, so to pop and stack, so here we are going to delete the element in a stack. So same thing, structure is created, so temp cell is created. So if it is s equal to empty, we are going to display an error empty stack, or else we are going to free temp cell and we are going to delete one element, and this s of next will be going to be next of next. So the value next the value is deleted. So So what are the applications of stack? So application of stack is evaluating arithmetic expression, balancing the symbols and Tower of Hanoi, and function calls 8 wins problem. Actually when we are invoking a function, we are going to start a program, there will be a process, there will be end of program. For that we should have what is happening. So end the program, you should end it, right? Any program if it start, it should be ending. So for that we have to have an stack, so we can easily we have finished the problem or not, we can execute that. For that applications stack is mainly used. So these are the applications. Why are we using stack editing? So these are the samples of applications. Next we are going to see about queue editing. So in the stack, this is only one end, we are going to insert, we have to delete it. But in queue editing, this is also same as a stack. I mean similar to stack, this is also editing, similar linear data structure editing, but it follows first in first out. Whichever comes first, it will be going to delete it first, or like that. Okay. So insertion will be in one end, deletion will be in another end. So in front it will be inserted, deletion will happen in the other end. Okay. So first in first out. Okay. So whichever comes first will be deleted first. Okay, so insertion will be happening in the last and deletion will be happening in the front. Okay, we will see and we will come to know. So example, like adding the reservation counter. So first person who will come, he will be getting process done and will go. So adding will be done at the back side, but process will be happening in the front side. So whoever comes first will be doing the reservation first, like that. Okay, so there will be NQ will be happening in front, sorry, DQ will be happening in front and NQ will be happening in the rear end. Okay, fundamental operations, it will be NQ and DQ. So process of inserting and deleting, okay, will be happening in the queue. So here also same thing, but overflow, underflow. So here same thing, queue is full, it's overflow, queue is underflow, I mean queue is empty, it's underflow. So similar to stack, here also insertion and deletion we will call it as two exception conditions. Okay. So how we are going to implement it? Same thing we are going to implement in arrays and using arrays and pointers. Okay. So here what we are going to, what's the concept behind it? So there will be two pointers. There will be only one pointer there, top pointer, but here we are going to using two pointers. So rear pointer will be there, front pointer will be there. So to insert an element, okay, to insert an element x in a queue, rear pointer will be incremented by 1, then it sets the queue of rear equal to x. So first element will be in x. So delete the element, the queue of front is returned and we are going to increment it by 1. Okay. So what is the routine? Okay, see it's very the array size is equal to rear. We are going to say the same thing as queue overflow, like in stack overflow we are going to do. For adding 1, we are going to add rear equal to rear plus 1 and we are going to insert an element to queue of rear. Okay, is it clear? Next, for DQ, so we are going to delete. So we are going to check if front is equal to 0 means it is underflow. Okay, or else we are going to change the front value. The pointer will change its value. So we are going to check front equal to R rear. So we are going to check it's both of them are rear. So if not only we are going to change equal to front plus 1. Okay, incremented. So here you are going to see the examples here. So normally starting empty queue front will be 0 and rear will be minus 1. So after one insertion both will be in 0. Okay. Then next another insertion happens, both front equal to 1, rear equal to 0. It's okay, nothing is deleted. Okay. So next 10 is deleted. So we are going to, both of them starts to be in 1. Okay, 1 pointer, the value is equal to 15. So after that 15 is deleted, R is -1 and F is 0. So it have both reset the value. So next we are going to implement in linked list. Okay. So Q has implemented using linked list implementation. First we have seen array implementation. Okay. So here in the linked list, NQ operation perform at the end of the list and DQ operation is going to perform at the front of the list. Okay. When we see, we will understand. So here also we are going to use the structure. Structure we are going to use for this. Okay, node is created. Structure node is created. It contains element and node of next and 2 pointers, front and rear. Starting it was null. Okay, and function declaration we have checked it is empty or not, and we are going to create a queue. Okay, and we are going to call make empty and NQ and DQ operations. Okay, so for insertion we are going to insert it. Okay, deletion we are going to delete the queue. So whether it is empty or not, for that is this is the routine for empty or not. We are going to check if Q of next equal to null. If it is null and Q of next equal to null, we are going to return 0. Okay, if value both are null, we are going to return 1. So we will come to know its Q is empty. Okay, next we are going to create a queue. For empty queue, we are going to allocate some space. So memory allocation according to the structure of a node, we are going to allocate the memory. So if Q1 equal now, it's out of space. Okay, then make empty we are going to call a function and we can create a queue. So what happened? Make empty. So make empty, if it's Q equal to null, we are going to we are going to put an error, create a queue first, or else we will empty the queue. Okay, we will do the DQ operation again and again. Okay, finishing the while loop. So how we will going to DQ? So whatever steps we are going to do. So we are actually creating a structure. Okay, name temp. So first we will check friend equal to null. So we will tell an error that is the queue is underflow, or else we will put a temp equal to friend. Here we will check it's both front and rear are equal. Then we will put an front equal to null and rear equal to null, or else we are going to do the operation of DQ operation. So front of next will go to front and we are going to print the data and free temp. So actually we are changing the list value. Front of next will go to front means the value is going to, the pointer is going to change and we are going to display the data. So we are actually simulating what is happening in a queue operation. So what is the NQ operation? So NQ operation we are going to same the structure node is created. Okay, we are going to allocate some space. We are going to check both are equal. Then we will new node we are going to happen. Then else only we are going to NQ. So NQ here see the data is saved to new node of data. Then data of next equal to null, or else rear of next we will change into new node and new node equal to rear. So we are going to add the according to the queue. We are going to add the queue. Okay. That's it. So I have explained about stack and queue.